Hello to all my viewers. I am Praveen Karthik and today we are going to talk on some basic concepts for astrophysics, specifically spectroscopy. Spectroscopy is a broad field that comprises several different subdisciplines and a wide array of techniques, each of which uses highly specialized equipment, that is spectrometer. It is the science of studying materials by measuring their response to different frequencies of radiation. It should be noted that while a few forms of spectroscopy used other forms of radiative energy, such as acoustic or matter waves, spectroscopy is virtually always understood to use electromagnetic radiation to probe matter. Spectroscopy is a fundamental tool of scientific study, with applications ranging from materials characterization to astronomy and medicine. Spectroscopy techniques are commonly categorized according to the wavelength region used, the nature of the interaction used, or the type of material studied. Let's explore the five most popular types of spectroscopy. IR spectroscopy, ultraviolet visible, UV/vis spectroscopy, nuclear magnetic resonance (NMR) spectroscopy, X-ray spectroscopy, and Raman spectroscopy. IR spectrum's photons have characteristic energies corresponding to those of molecular vibrations. Thus, the vibration and rotational modes of molecules can be studied using IR spectrum waves. IR spectrometers typically measure the relative absorption of different frequencies in the IR region by a sample. This absorption spectrum can then be used to identify the type of molecular bond present in the sample, indicating the type of molecule and structures present in a sample. Energy levels of electrons, also called electron shells, are fixed distances from the nucleus of an atom where electrons may be found. As you go farther from the nucleus, electrons at higher energy levels have more energy. Atomic electron transition is a change or a jump of an electron from one energy level to another within an atom. It appears discontinuous as the electron jumps from one energy level to another, typically in a few nanoseconds or less. The UV and the visible regions of the electromagnetic spectrum correspond to electron energy level transition in atoms and molecules. Therefore, the UV and visible spectrum can be used to probe the electronic structure of molecules in a sample, subsequently enabling identification of the compounds present. This spectroscopy is particularly useful for identifying peptide bonds, certain amino acid properties, etc. Resonance in physics is a phenomenon in which an external force or a vibrating system forces another system around it to vibrate with greater amplitude at a specified frequency of operation. Resonance frequency is a natural frequency where a medium vibrates at the highest amplitude. Nuclear magnetic resonance spectroscopy, that is NMR spectroscopy, is a technique used to measure the magnetic fields that exist around atomic nuclei. NMR spectroscopy uses radio waves to excite atomic nuclei in a sample. When nuclei start to resonate, this is detected by sensitive radio receivers. As the resonance frequency of an atom nucleus depends on the electronic structure or the molecule of which it is a part. NMR spectroscopy provides detailed information about the structure and reaction state of molecules. It is hence a powerful tool for deducing the exact nature of certain organic compounds. A crystalline material consists of primarily organized crystal structures. A crystal is a solid composed of atoms, ions, or molecules arranged in a pattern that is repetitive in three dimensions. Each crystal structure within a specific crystal system is defined by unit cell. William Henry Bragg and William Lawrence Bragg showed that the diffraction patterns created by X-rays passing through crystalline material could be used to deduce the nature of the crystal structure, called X-ray crystallography. The use of X-ray spectroscopy began with the development of X-ray crystallography in 1912. Two other X-ray spectroscopy techniques are commonly used today. Wavelength dispersive X-ray spectroscopy (WDXF), a method used to count the number of X-rays of a specific wavelength diffracted by the crystal, and energy dispersive X-ray spectroscopy (EDXS), an analytical technique which provides surface elemental analysis. Both techniques enable elemental analysis by measuring characteristic X-rays within narrow regions of the spectrum. Raman scattering or the Raman effect, the scattering of photons by matter, meaning that there is both an exchange of energy and a change in the light's direction, both of which are irreversible or inelastic in scientific terminology. Raman spectroscopy uses Raman effect with a source of monochromatic light, that that is single wavelength light source, to illuminate a sample. When the laser light interacts with molecular vibrations or other excitations in the molecular system, the energy of the photons is shifted either up or down. Accurate measurements of these energy shifts enable a detailed analysis of the types of chemical bonds present in the sample. Raman scattering provides similar yet complementary data to IR spectroscopy. Some components of a spectrograph used in spectroscopy are collimator, monochromator, detector, and an electronic processing unit. A collimator is a device that narrows a beam of particles or waves. Collimation is achieved by using a series of closely spaced parallel metal plates or by a bundle of tubes with extremely low diameter. The light from stars, whose distance are measured in light years, arrives precisely collimated because stars are so far away they present no detectable angular size. However, due to refraction and turbulence in the Earth's atmosphere, starlight arrives slightly uncollimated at the ground, with an apparent angular diameter of about zero point 0.4 arc seconds. Although collimators improve resolution, they also reduce intensity by blocking incoming radiation, which is undesirable for remote sensing instruments that require high sensitivity. For this reason, the gamma ray spectrometer on the Mars Odyssey is a non-collimated instrument. Most collimators let less than 1% of incident photons through. Attempts have been made to replace collimators with electronic analysis. Monochromator systems partially polarize and unpolarized beams. The main goal of a monochromator, either metallic filter or diffraction grating in a non-visible spectrum, is to separate and transmit a narrow portion of the optical signal chosen from a wider range of wavelengths available at the input. A prism is a well-known monochromator component for the visible range. The detector is a device which converts the radiation energy into the electrical signal. It is the intensity of the radiation which is subsequently digitally processed and produced at output of instrument. These detectors may work on different principles, but ultimately they show us the amount of output radiation. Some detectors are photon detectors, thermal detectors, and X-ray detectors. These are many types of detectors within each category of detectors, each catering to a wavelength or application. Electronic processing units not only convert electrical signals from detectors into normalized data for a computer to process them, but also to provide electronic controls to the spectroscopy. The ability to interface with the computer is absolutely essential for any modern spectroscopy. With this, I conclude my gist on spectroscopy and hope you enjoyed it. I thank all my viewers for their support and enthusiasm. I thank my school teachers and my parents for teaching me, encouraging me, and helping me in accessing high quality content. Credits go to the respective sources for the extracts of information I understood. They are Wikipedia and various textbooks, like Field Guide to Spectroscopy by David Ball. This content is curated by me, but none of the sources have endorsed this recording. Thank you.